Cool. So what I'm going to do, I'm going to have a look at the partial application, function application. It's okay if you don't know what that is. But do you know what, like, Python, like, that's the most common, most popular language? Raise hands if you've done Python before. All right, that's good. That's good. Assuming, well, let's define partial function application first to be on the same page. Cool. So a silly example to explain that for the people who might not know it. So there's a power n function, which it's the result x to the power of n, right? That's simple. And if you print to the power of 3, it would be output would be 8, right? Easy. So Python has this this library called functors, right? Which is part of the Python. It's not extra, and have this function called partial, right? So if you use that function and give the power n, for example, here as an argument, and say, hey, I want to have the x, remember x from the previous one, as 2, and I want to fix it, it gives you another function. It's called power2, which the number x, well, the argument x is fixed with 2. So now if you do a print power2 and only give it 3, you don't have to give it 2, remember 2 is fixed, it gives you out 8, right? It's the same thing in terms of result. So how many of you, raising hand, knew about this and used this before? 3, 4? I don't see the people from here, but yeah. Okay, that's good. That means I'm in the right place. A lot of you know about Python, but not many of you know about this. Okay, good. So, so that was my question too. So to be honest, like maybe a few years ago, when I was learning about this, I was like, who would use this? Python is not a functional first language. Why would you do this? So I did a bit of deep exploration. I did it the hard way, because the silly examples like power n wouldn't help. Like, well, how would we do this in Python? So I did search across all of the GitHub using the search capability. Looked into the more popular Python repositories, more than 100 stars, and I found a few. Well, I found plenty. Excluded the forks. And some of the examples were interesting. So I'm showing you the interesting ones. There are a lot more interesting ones, but I picked just a few. The one I liked myself, and there were things to learn from them, right? The first one is Panda. I think most of you working with Python probably learn about Panda as well. So it handles environments, handles packages, so you can create a new environment with a name and say, hey, everything related to Python, which I'm working with, is in this. Don't impact other. You can create different environments, right? But also there's a function called Panda rename, which you could rename the environment, right? From old name to new name. And if you do a dry run on it, /d, it would give you, without running the actual command, it would give you this. So if I run this command, I would clone this into the new path with a new name. Every name is a new path. And then rmrf, remove the old one. That's a dry run. Yeah. So let's see how Panda did this using, actually ingenious, using partial functions. So that's the function clone and remove is the one who does this. They define an action, which is tuples of 2 partial functions. First one is the clone, which has source and destination, of course. The second one is rmrf, with the source, of course, right? And then the way they do this, they go through the actions. If the argument was dry run, they print the name and arguments of the function. Otherwise, they run the function, which is essentially running each of these functions, which is the clone and the arguments, right? Isn't that nice? Doesn't anyone know why they use tuples and not arrays or lists? Yes. Anyone?
Composability, you know, run together. So if you've got a whole list of things, you can execute the whole lot in a set.
Yeah, but why tuple and what not the list? They could have used a list. Because it became immutable. So you can't add to it later on. You can't change it. So those are byproduct of this learning. They're looking to search. You could learn more. Okay, well, pip. I'm pretty sure everyone uses pip. And also has options. So this -- help is an option. They call it option, right? So each option in pip is a class and has a function called process, which you call this, it would do whatever that option needs to do, right? But the way they implement and initialize, I should say initialize the options is through partials. So they create, per each of those options, a partial function, which the option which I showed you before, by the way, this can be a class in Python as well. It's not always a function. And then these are the arguments. These are the basically, since option is a class, these are the properties of that class. So initialize those properties, and then they make a list of it, and then by the time they run, they would look for, hey, which type of option I have, and then they run the process. They run the process function, which I showed you the previous slides on it, right? So this way they create they initialize, they make all of the options without actually initializing them. They give all of the properties values to the class without actually initializing, making an instance of the class. And then later on at the time of process, at the time of the running the actual command, those options would be running. Yeah, so they delay the execution of that class initialization, okay? That's another good one. Well, one of the great ones is this one, ByDictionary. It might not be as famous. By the way, anyone uses ByDictionary? Yeah, you heard of it? So it's interesting. So it's a two-way dictionary, right? So each time you add to this, it's like you have two different dictionaries. One is from key to value, the other one from value to key. It always keeps it consistent, right? So an example of this is and B is of type of ByDict. If you define a ByDict and put the value, put the key for with the value for, or for a string, and then you could print B invert for, and it gives you the string for. Yeah, that's what it does. It's useful for the way I use it myself was for the country names and country codes. If you want to have a high performance dictionary which does both, you know there's always a one-to-one between these two, you can use it. Cool, but it gets more complicated. ByDict has this put all function, right? Which you can add a list of entries to the ByDict, right? And it might fail at some point. So have a look at this example, right? So we have 1 and 2, and then by the time we want to add 3, it's all good. By the time we want to add 1, because the 1 already exists, right, it would fail. Yeah. But the way ByDict is designed is when you use put all, either all of them would be stored, added to the dictionary, or none. Yeah. So by the end of this, the whole ByDict dictionary wouldn't change, right? There's another thing I should add that you can decide. There's another option you can decide what to do when a duplication happens. Should I drop the new key? Should I drop the old key? Should I throw an exception? So you can decide on that, right? So now let's see how ByDict does it. So it's a lot of code. It can be complicated, but really easy. I tried to make it as simple as possible, but it can't be any simpler than that. So the way it does it look at the for each, this is the loop, like that's a loop through all of the items you want to add to the by-date dictionary. Okay. It tries call the deduplication, right? So remember I said for each of the items, it might be different policies of that deduplication. It might be overwritten, it might be drop, it might be true exception, right? And if there was an exception at some point, try this unwrite list. Yeah, so this way it's like Control Z. It's like unwriting whatever written before. Undo the writes if there was an exception at some point. Otherwise, continue with the writes. And the way it does it is makes two lists by preparing the write, calls the prepare write function, and prepares a list of write and unwrites, right? And it makes sense. So that's a loop. If there was an exception, run the unwrite ones. While there is no exception, always call the write operations in the write list. Yeah. So the point I want you to take away from this is the key is prepare write. So before writing, it prepares the operations to write and unwrite. As long as everything is okay, no exception, continues with writing the write operation. If there's an exception, runs all of the unwrite ones. Okay? So now, have a look here. This is a prep write. So per each, so this is too simplified. It's a bit simplified of the original version to make it clear. So the original ones were very more complicated. So this is two dictionaries. Remember, this is YDic, two-way dictionary. Two dictionary, forward one and the invert one, right? This is to add a new key to forward one. This is to inverse one, yeah? So it makes two lists, remember. Write list is to add to both dictionaries. Unwrite list is to remove from the both dictionaries. And that changes based on what duplication policy you would pick. But have a look at the partial. Okay, all of the operations with simple functions can be created in a list, and then at the time of the writing can be used. Cool, there are other findings too. TensorFlow does it, Pytorch does it, Home Assistant is another IoT library which does that too. So yeah, so have a look at my blog. So there's more examples there, which I couldn't put into these slides, but there's a lot. Yeah, so I'll stop here for questions.
Thank you very much, Amin. All right, we have a couple of questions. First of all, somebody who is new to Python, but they ask, is a partial function the same as a lambda closure and closure from other languages?
There are some differences. So the partial functions, but lambdas, well, they're really different. So the partial functions are for freezing or fixing the arguments of a function, right? Mm. So ideally, you want to decrease the number of arguments to a point which make it usable for that use case, for the problem you're solving. Mm-hmm. So normally, you would decrease it to 1 because you can put all of them in one list, because you could make a tuple out of it. So that's the use case, but the others are used for different purposes. Like a lambda is used for making an inline function or making a function within the map, things like that.
All right. When you passed option instead of a function, is it like a partially applied constructor? So fully applying the partial gives you a fully initialized object?
Yes, it would be like a partially applied class, right? So normally when you call a class, you would call the initialize function on the class when you initialize it in Python, right? But this way, that function wouldn't be called. So only those arguments would be, those properties would be set value. Yep.
Awesome. And the last question at this stage, have you tried asking an AI to generate a partial function? If yes, how accurate is the code?
Well, well, I haven't tried it, to be honest. Also, another note, which a good reminder is, so the reason I had to do the search myself, because apparently, like, Copilot and AI are not very good as, like, these kind of use cases. If you tell it, hey, like a query like this, go across the whole GitHub and find all of the use cases of partial application, which has this specific property, like semantic searching. Copilot doesn't give you a good result. Like you have to do the search yourself. Well, that's the way to design.
That's it on the questions.
Awesome.
Thank you very much.